I'm going to talk indeed about gender, competitiveness, and career choices. And the motivation for my talk is that gender differences in labor markets are still very persistent. Even though they're having a lot of advances, the differences are still very striking, both horizontally but also vertically. So when you think about vertical differentiation, for example, in the MBAs at top-tier business schools, only about 30% of them are female. For US firms, only 2.5 of the 5 highest paid executives are female. Fortune 500 companies, women only make up about 4% of CEOs, 14% of executive officers. And also in the EU, there are fewer than 14% of board members being female. But there are differences also on horizontal segregation, and especially that women are not going to what is called the STEM fields, science, technology, engineering, and math. So in Europe, where we love giving people choices early on to decide what to do, girls are much less likely to opt for science tracks, both in high school but also in college. In the US, there are actually no more gender differences in how much math boys and girls take in schools. However, there are differences when you look at very high achieving math Olympiad kind of classes or exams. And there's a very nice paper by Ellison and Swanson that addresses whether this might be due to ability or because of other reasons. Okay. And basically the idea is when you take this equivalent of the American Math Olympiads and you think that who is going to show up there is going to be the most talented people, then you would imagine that those people should come a little bit all over the US, maybe some concentration on the East and West Coast because there are more people living there, but it should come from all over the US. And that's actually the case for boys. It's not the case for girls. The girls who show up in these Olympiads all come from a very small subset of schools. Okay, so this suggests that it may not be necessarily a difference in ability, but there is something else in place. In the US, on the college level, there is also a significant gender difference in how much math and science boys and girls take. And there too, there's some evidence that this is not just because of differences in ability. Okay. So how can we explain both this vertical and this horizontal segregation? The standard explanations are discrimination and differences in abilities or preferences. Okay, so maybe women are not as smart. We already showed that presumably, at least when we think about the highest achieving children in the US, it doesn't seem to be ability. But it could be differences in preferences. Maybe women want to spend more time at home rearing children, so they don't want to be CEOs of companies where they have to work a lot. But recently, literature has developed that thinks about other possible explanations. For example, it could be that women react differently when they have to bargain. Maybe women are not as good in bargaining. Or it could be that women are less good in assigning tasks that lead to promotion. Or it could be that women are less willing to seek out promotions. Or there could be gender differences in competitiveness, okay, engaging in demanding and competitive tasks. So today I'm going to talk about the last one, but there is some evidence for each of the other ones. Okay, so what I'm going to try to do today is to convince you that we have a psychological attribute, we can call it a non-cognitive skill, that is both very robust and large when we look at it in the lab, but it also has some bearing for what we actually care about, namely these gender differences. In this case, we're going to think about vertical segregation, why women have different educational outcomes than men. Okay, so I want to first establish this gender difference in the lab. I'm going to show you it's large, it's very robust. Then we're going to think about external relevance. Is this concept actually helping us understand what we want to understand in the first place? Namely not how people perform in the lab, but how they do outside of the lab. And then we can think about avenues of future research. I'm just going to spend very little time on that, but obviously that's where I think things should go next. I'm not going to tell you about all these papers, but you can see I have a lot of male co-authors, so even if you're not female, it's okay to study gender. So I hope I don't just talk to half the audience here. So when we think about establishing gender differences in competitiveness, the psychologists have talked about this for a long time. Okay, so basically boys spend much more time on competitive games than girls, like running, whereas the girls, they really like playing house, or games that have no clear endpoint or no winner. Men also describe themselves as being more competitive than women. Okay? But as economists, the question is, are we still going to find differences when we level the playing field? Maybe boys are faster runners, so of course I'm not going to start running with the boys. It's not going to be fun if I'm going to lose all the time. Okay? So I don't have to convince you why experiments is a good way to go for that. But the advantages with experiments is that we can control for self-selection issue. We can really measure performance. There's no issue of discrimination or belief discrimination. I don't know exactly how I'm going to pay people, and they believe me because we don't deceive them in the lab. There's also no issue of career concerns or time commitments. My experiments take an hour. If people want to have children and care for them, this 1 hour is not going to hinder that at all. So I want to start with the first experiment where we looked at gender differences in choice of competitive environments. This is joint work with Lisa Westerlund. And we ran this experiment in Pittsburgh. We had 80 students from Pittsburgh and Carnegie Mellon University. We put students in groups of 4, 2 men and 2 women. They had to perform a real task, which was to add up 5 two-digit numbers. Okay? This is how we showed the task to them. And they saw these 5 numbers. They had to put in the sum. They clicked a button. Then they would get to see whether their answer was correct or not, and they would get a new problem. Okay? And the task was to do this for 5 minutes. Okay, and the performance was how many of them they solved correctly. So there was no penalty for any mistake, but if you didn't solve it correctly, you didn't get a point for it. In our experiment, subjects performed this task many times. Every time I perform the task, I know what my own performance is, but I don't know anything about other people's performance. Furthermore, in our experiment, we never ever mentioned gender. Okay, so this was the first one we did on gender differences in selection. We were really worried that if we mention gender, people may think, oh, this is a gender experiment. So we made sure not to mention gender at all. So we had them perform this task multiple times. One of the times was paid. The first time they performed the task, we say, if this round is chosen for payment, then they're going to get 50 cents for every correctly solved problem. So at the end of this first round, again, I know how many I solved correctly, so I know how much money I would earn if that round is chosen for payment, and that's all I know. At the end of the first round, we tell subjects the instructions for the second round. The payment for the second round is as follows. We tell them, now you're in a group of 4 people. It turns out to be 2 men and 2 women, but we don't mention gender. But we just made it that every row had exactly 2 men and 2 women sitting in that row. Okay? So they could see the gender of their competitor, but we don't mention it to them. Okay, so we tell them, if this round is chosen for payment, then only one person in the group is going to get paid, and that's the person with the highest performance. Okay, this person is going to get $2, 4 times as much for every correctly solved problem, and everybody else is going to get nothing. Again, at the end of this experiment, the only thing I know is my own performance. I do not know after round 2 whether I won the tournament or not. I don't even know how far, what the performances of other people were. Okay? I just know my own absolute performance. Okay, so after subjects have experienced both the piece weight and the tournament, now comes the stage of interest. That's when we have them choose what they want to do for their third task. Okay, so we tell them you're going to perform one more time, and now you decide how you want to get paid for this performance. They can either choose piece rate. If they choose piece rate, it's easy. They're going to get, if round 3 is chosen for payment, they're going to get 50 cents per correct problem. If they choose tournament, we have to decide, okay, who are they going to compete against? Okay, and what we said is, if you choose tournament, if I choose tournament, I'm going to compete against the round 2 tournament, the round that just happened before, the performance of the round 2 tournament of all my group members. As Arno said, I'm from Vienna, so I'm from Austria, so we do a lot of downhill skiing. So I guess you don't do that in the Netherlands, sorry, but you may have watched it anyway. Suppose everybody skis down the hill, okay? And then if I choose tournament, what happens is that I get to ski down one more time, and I'm going to compete against the old time of everybody who skied down before me. Okay, so I don't have to compete against myself, but I have to compete against the old times of others. The advantage of this is that I actually literally don't care what my group members are choosing, because their performance in round 3 has no impact on my payment in round 3, because I compete against their round 2 performance. Okay. That's important because it means subjects don't have to form beliefs, I don't have to address these beliefs or get those beliefs from subjects. Okay. So what should people do in round 3? Well, as an experimenter, I know the answer because I know what performance would be a winning performance. So we can compute, given the round 2 tournament, how many people, if the round 3 performance is just like the round 2 performance, how many people would have had more money from going to the tournament. Okay, this turns out to be 30% of women and 30% of men would have strictly made more money from going to the tournament. If we include those that are indifferent, those that basically have a 25% chance of winning, then we would have 40% of women and 45% of men. Okay. So who actually enters? We have 35% of women entering and 73% of men entering. So with that, this turns out to be significant, but you don't need a big lens to check whether this is significant. So who is entering the tournament? I'm going to show you for each performance quartile. So think of the first performance quartile on the right, the best 25% of subjects. I'm going to show you the fraction of men and women who are entering the tournament. So it turns out that about 40% of women are entering the tournament and 75% of men are entering the tournament. If you are in the best quartile, you should enter the tournament. You're going to make more money if you enter the tournament. If you're in the 3rd or 4th quartile, you're never going to win the tournament. You should not enter the tournament. Okay? Nonetheless, the men who are in the worst quartile have a higher chance of entering the tournament than the women who are in the best quartile. Okay? So this gender gap happens for all the performance quartiles, and that also immediately shows you who is going to make mistakes. The people who are going to make mistakes are the high-performing women. They're actually making very costly mistakes because they are choosing the piece rate, which gives them 50 cents per correct problem, instead of going to the tournament, which they have a very high chance of winning and getting $2 per correct problem. The other group of people who make mistakes are the low-performing men. But the low-performing men, they're not going to make much money anyway. Okay, so if they go to the tournament, they're going to make 0. If you go to the piece rate, maybe with a performance of 6, they're going to make $3. So they also make mistakes, but much less costly mistakes. Okay, so we showed that performance cannot account, or actual ability cannot account for the differences in choices between men and women. Okay, but how about beliefs? Right, in the end, my choice, I only know my absolute performance. My choice has to depend on my beliefs about my relative performance compared to other people's performance. Okay. So it could be that the beliefs of men and women are very different about their chances of winning the tournament. So after people have made all the choices, but before they get any feedback, we're going to elicit those beliefs. Okay, we're going to ask people, what do you think was your rank in the round 2 tournament where everybody had to go to the tournament? Do you think you were 1st, 2nd, 3rd, or 4th? And if they're correct, they're going to get $1. So there's going to be 2 issues. One is, are there going to be gender differences in beliefs? And the second is, well, if we found gender differences in beliefs, they're going to help us understand why men and women enter tournament at different rates. So on the next slide, I'm going to show you the beliefs of men and women in our experiment. Remember, we have 40 men and 40 women in our experiment. Okay, so I'm going to have 40 people, 40 men who I'm going to ask about their rank, and I'm going to have 40 women who I'm going to ask about their rank. Okay. Of my 40 men, 30 thought they are the best in their group. Okay. Most of them are wrong. But I also have a lot of women who think they're the best in their group. Okay? So when you look at those numbers, what you see is that both men and women are overconfident, Men are kind of even more overconfident than women are. But we have roughly 75% of men, or we have exactly 75% of men, and we have about 40% of women who think they're the best in the group. Remember, we had 35% of women entering the tournament and 73% of men. Maybe I just found the people who entered the tournament. Maybe I don't need to have another measure of competitiveness. Maybe I just found the reason why I have this gender gap in tournament entry. It's all gender gap in beliefs. So to address this, I'm going to show you a figure where I'm going to show you, as a function of my belief, what choice am I going to make. And I actually, here's a figure. Of the people who think they are the first in their group, roughly half the women are entering and 80% of the men are entering. So beliefs are correlated with tournament entry. The better I think I am, the more likely I am to enter the tournament. But even conditional on beliefs, I still have a gender gap in tournament entry. Again, if you want to understand how much beliefs account for the gender gap in tournament entry, figures are only going to get you that far, so we can run a regression. And it turns out the gender gap of tournament entry of roughly 40 percentage points, about a third of that is accounted for by beliefs. Okay, so beliefs are important, but they're not going to be able to account for everything. We also have controls for risk, aversion, and differences in wanting to get feedback about your performance. And even those cannot account for everything. Okay, so what we're left with is that we have this big gender gap in tournament entry. 1/3 of it can be accounted for by beliefs, and then we have a small residual that can be accounted for by gender differences in risk aversion and willingness to receive feedback. And then we have this big residual, which we're going to call gender differences in competitiveness. Okay. So what is nice is that this experiment has been replicated many times, and not just by me and my co-authors, but by lots of other people as well. So it seems to be a robust result. The impact of confidence, lots of papers have shown that beliefs or confidence is really important for this result. Confidence robustly explains about 1/3 of the gender gap in tournament entry. Another way to see this often is that when you take stereotypical female tasks, the gender gap in tournament entry is often much smaller, sometimes disappears. We don't have a good handle yet on what is maybe the right stereotypical female task or how we can make it disappear completely. Okay, but once we control for beliefs in tournament and performance, we still have a significant gender gap in tournament entry. Risk, I mean, economists, really, every time I give this talk, the economists always love saying it's all gender differences and risk aversion. Risk in general only has a very small impact on those choices. This is actually not surprising when you think about what lottery I'm choosing if I enter the tournament or if I take the piece rate. But if I'm a very high-performing woman, I'm actually almost certain to win the tournament. And I get ridiculous amounts more money because I get $2 per correct problem. If I choose piece rate, I just get 50 cents per correct problem for sure. It's true that many experiments find gender differences in risk aversion, but these differences are often tiny. You would need gigantic differences to get this result. Okay? So risk aversion often has not a big explanatory power on this gender gap in tournament entry. So then the next question is competitiveness important? So lots of papers, luckily for us, have picked up this line of reasoning and said maybe it can help us understand why women don't study sciences, why women don't become CEOs. But let's be honest, that's a big of a leap. And the question is, should I indeed tell my labor colleagues that this is a result that they should care about? So the way I want to think of this is whether this trait has external relevance. Can it help us understand, as I said, why women don't become CEOs or why women don't study sciences and engineering? Okay, and specifically, what I'm going to tell you next is we're going to think about the educational environment. So we're going to think about whether it helps us understand why women don't become scientists. Okay. I want to have a little side note on how to think about this whole external validity question, because I think economists have a little bit hijacked that term. Okay, so often, the way people address external validity is they go to the field. Okay? So what I could do is, if I go to the field obviously has lots of advantages because maybe it's nicer to run experiments not with students to potentially have higher stakes, but the drawback is I obviously have much less control. It is much, much harder to replicate. Okay, one advantage of the initial lab experiment was that lots of people replicated it because they changed some treatments. It would be much harder to replicate a field experiment. So suppose I run a field experiment with Austrian farmers. Okay, I'm going to give them different incentive schemes for whatever, cutting hay or driving cattle on top of the mountain, whatever Austrian farmers do. The problem is you have no idea what Austrian farmers are doing. Okay? You cannot, presumably, maybe apart from Arno, understand whether this is a meaningful task that they're doing often or not. Okay? So when you go to field experiments, I think sometimes more thought has to be put into what is the right subject pool, what is the right question. Okay, so I don't want to say field experiments are bad. That would be a mistake. You should not get away with that feeling. I'm just saying that sometimes they get too much important compared to lab experiments. I think both of them are equally good. They may have different strengths and weaknesses. I don't think one of them is particularly superior to the other. But I also want to point out that if you want to understand if competitiveness helps us understand gender differences in education, going to Austrian farmers is not going to help you. If you want to understand whether gender differences in competitiveness help you understand why women don't become CEOs, going to Austrian farmers is not going to help you. Okay? So when we think about external validity, I think often what we mean is external relevance. Can this trait help me understand what I was interested in the first place? Namely, do women not become scientists because of competitiveness? Do they not become CEOs because of competitiveness? Okay, and this is exactly what we want to do next. Can competitiveness help us understand some of these gender differences in science, technology, engineering, and math? So this is joint work with Thomas Buser, who is sitting in the front, and Hessel Osterbeck, both from Amsterdam, and is already forthcoming. And the main questions we're going to ask is, controlling for academic performance, is competitiveness going to correlate with study profile choices, or what children are going to choose in high school? And I just want to point out, what this shows is that competitiveness is an important trait. Okay? This is not the same thing as saying that competitiveness helps me understand the gender gap in those choices. These are basically two distinct questions. Okay? It could be that the answer would be yes to the first one, no to the second one. I would still be happy because it shows that competitiveness is an important trait. Obviously, if you can say yes to both, that would be even nicer. Okay, so we go to the Dutch school environment, which I bet many of you here are much more familiar than I am with. And in the Netherlands, the way it works is that the 20% best children get chosen to go to what is called the pre-university track. This is their last 6 years of high school. For the first 3 of these last 6 years, they all basically sit in a class next to each other. They all have the same teachers and the same curriculum. And then they have one choice to make about what classes to take for the last 3 years of high school. And basically, there are 4 tracks in the Netherlands that they can choose from. One is the nature and technology track. Think of that as a math track. The other one is nature and health track. For those of you who are not Dutch, think of that as the biology track. Then we have the economics track, and then we have the literature track. Okay? So the above is not just the order of how much math and science there is, but also the order of how prestigious it is, where the best children go. Okay? And the result is that in the Netherlands, girls are much less likely to choose the math track and much more likely than boys to end up in the literature track. Okay. So here is, for those of you who are not from here, here's the amount of hours those children have to take for the last 3 years of high school, depending on the tracks. And that just confirms that if you take the math track, you're going to have more math and science than if you take the biology track, the economics track, or the literature track. And for mysterious reasons, the ordering of how difficult the math classes are is D, B, A, C. Okay? Here is what children do after they have taken these different high school tracks. So clearly, what high school track they choose has an impact on what college they go to, what they study in college. That's also because some colleges actually have certain math requirements. So if you want to study math, obviously you have to have certain math requirements in order to be able to do that. The second thing you note is also the chance of actually going to university is indeed highest for kids who chose the math track than biology, economics, and literature. This is the distribution of children in the Netherlands of choosing these 4 tracks. And you can see that boys compared to girls are much more likely to take the math track, NT, and girls are much more likely than boys to take the literature track. And there was actually some debate in the Netherlands whether they should abolish this literature track, because it's a bit like a trap. Right? Once you chose it, you can't really get out of it, and it really limits what you can study afterwards. Okay, but in the end, they decided to leave it for now. Okay, so what we do is we have an experiment where we managed to get 4 schools in and around Amsterdam to allow us access to every single one of the 9th grader. Okay, that's the last year where they still have classes in common before they have to make that choice. We have almost 400 students, but in the end, we're going to have to eliminate some from our analysis because they come late and they miss some of the experiments. We don't have some of their data. We ran the experiment in March, April, and May. Within a school, Thomas and colleagues, often ran it on the same day, but sometimes even exactly at the same hour. Okay? So we're worried that children would learn from each other. We were not worried that they would learn across schools from each other. Okay, so we ran these experiments in March, April, May. Then we get from the school data at the end of June or in the summer. So we have one class hour for every single 9th grader. The first thing we're going to do is we're going to get a competitiveness measure, and we're going to use basically the Niederle-Westerlund design I just showed you before. We're going to adapt our task a little bit. Instead of adding up 5 two-digit numbers for 5 minutes, they're going to add up 4 two-digit numbers for 3 minutes because they are 15. We're going to have to do it by paper and pencil. They're going to perform for 3 rounds. One of them is chosen for payment. They get no feedback. Here, it's easy to see because they just do it on paper and pencil. They submit the whole forms to us, and we have to go home, and a week later we come back to school and we give them results. One of the rounds is going to be chosen for payment, and as I said, we pay them a week later. Okay, so the first round is the piece rate round. We adjust the payments. They get €0.25 if you do everything correctly, per correct problem, sorry. Then round 2 is a tournament. They are told that they're going to compete against 3 random classmates. They don't know who they're competing against. We don't know either yet, because remember, we're going to do this once we go home with all the forms. But they know they're going to compete against some of their classmates. In round 3, we have the choice. That's, again, just as before. If they choose piece rate, and round 3 is chosen for payment, they get €0.25 per correct problem. If they choose tournament, we're going to have them compete against the round 2 tournament of their group members. And if they win, they get €1 per correct problem. Otherwise, they get nothing. Okay? So it's exactly like the experiment before, only that now we have children competing against their classmates. They don't know exactly which of their classmates, and everything is scaled down a little bit. Okay, then we also ask their confidence. We ask them in the round 2 tournament where everybody had to perform, what do you think your rank was? We also have some risk questions. We use 2 kinds of risk questions. One is an Eckel-Grossman style risk question. They have a choice between 5 options. They can either have €2 for sure, and they can pick one of 4 50-50 gambles of either €3 or €1.50, or €4 or 1, €5 and half a euro, or €6 and nothing. Okay? So if you're risk neutral, you should pick the last one, has the highest expected earnings. But if you're extremely risk averse, you might want to pick the €2 for sure. The second risk question is we use a dome-and-fight kind of question. We ask, how do you see yourself? Are you generally a person who is fully prepared to take risks? 0, unwilling to take risks, up to 10, fully prepared to take risks. Okay? We picked that because Falk showed that this is seems to be working well and seems to correlate with what people do outside of the lab, so we ask this question as well. Then we have some, you can call them fluff questions, they're non-incentivized questions. We ask them how good they think they are in math. There are two reasons to do that. First is, we have worried a little bit that the math grade may not be the best measure of true mathematical ability. And it could be that they have already some idea that maybe they're just very good in doing exams, but they have to really study very hard, and actually math is really difficult for them compared to maybe, so maybe I just described my little brother, but maybe for me math is easy, I don't study, I can solve the difficult problems, I just make mistakes on the easy ones, so our grades might be the same, but clearly our mathematical ability is going to be very different. So we asked them, how good do you think you are in math compared to other people in your year in school? And they did tell us if they're in the top 25%, next 25%, and so on. This is obviously not incentivized because I have no idea what their true ability is. I just know their grades. The second thing we do is we ask them, how difficult is it for you to pass the math class? Okay? From very easy to 10 very hard. Okay? So one worry is that this is already taking away a lot of the psychological effect. That's fine, I just make my life harder. The other thing is that this is actually a better measure of true math ability, and that's obviously great because it would be nice to have a perfect measure of math ability. We also asked them, what profile do you plan to pick in June? And then we asked them, what profile do you think the best students pick? And then from the schools, we actually get the grades of the students, and we get the profiles they actually pick. Okay. So first, I want to convince you, if you're not from the Netherlands, that this order of math, biology, economics, and literature is the order not just of how much math and science there is, but it's also the order of prestigiousness, where the best children go to. Okay, there are two ways to think of this. One is, well, we can just look at the GPA of kids who choose each of those tracks. But the other thing is we also ask children, what profile do the best students pick? So here is the GPAs of boys and girls who go to the math track, biology, economics, and literature track. Their math grades, where 1 is the lowest grade and 10 is the highest grade. Their relative math grade, so this is compared to my classmates. How hard they think math is for them, where 0 was very easy. And how good they think they are in math compared to their peers. And you can see that for basically almost all the measures, kids who go to the math track and T are better than those who go to the biology track and H, economics track, ES, and literature track, CS. Okay. When we ask directly the question, where do you think the best people go? Roughly 70% of children agree that the best kids go to the math track. Roughly 60%, or 57 to be precise, agree that the second best children go to the biology track. The third best children go to the economics track, and 80% of children agree that the least prestigious track is the literature track. Okay. In the paper, we sometimes use the student-specific ordering of track choices. Okay, suppose I just have the opposite ordering. I think actually literature is where the best children go to, followed by economics, biology, and math. And suppose I took the economics track. I would have basically taken the second most prestigious choice, given my own ranking. But everything I'm going to present you today, we're not going to take this into account. We're going to take this ordering as given, math, biology, economics, literature. But you can do everything in a student-specific ranking, and the results are basically the same. I'm not going to show you too many tables. So for the talk today, I'm going to focus on this ordering of math, biology, economics, and literature. So here is the GPA and the grades of boys and girls in our sample. As you can see, the girls have a slightly higher GPA than boys. That's significant. It's actually not so surprising. That's true in many cases. In 9th grade, girls are actually better than boys. For math, boys are a little bit better than girls, but this is really not significant. This difference is tiny. But boys feel that they are better than girls are. Okay? When you ask, how hard is it for you to pass the math class, boys give significantly lower numbers, so they think it's significantly easier than girls do, and they also rank themselves more highly within their peers. So there are no objective differences in terms of grades, but there are definitely some subjective differences in terms of how they feel about their mathematical ability. And some of that could be true math ability. I don't know how to measure true math ability. What choices are they making? Well, in our sample, 40% of boys choose a math track compared to only 17% of girls. And twice as many girls, almost, than boys choose the literature track. But if you add up the top two tracks, both of them being science tracks, compared to the bottom two tracks, we both have 50% of boys and 50% of girls going to math and biology compared to economics and literature. But within this section, the boys are always choosing the slightly more prestigious tracks than the girls are. Okay, so academically, boys and girls are very, very similar, but they make very different choices. So now we're going to try to understand why they make those different choices. So I'm going to show you a bunch of ordered probit regressions where we're going to take the ordering of math, biology, economics, literature seriously. And one advantage of the ordered probit regression compared to, say, an OLS regression is that you have more flexibility. The disadvantage is it's basically impossible to interpret. So let me help you understand what you're going to see here. In an ordered probit regression, think of an OLS regression. An OLS regression, the difference between each track is always 1. Right? That's kind of my definition. In the ordered probit regression, we're going to let the data tell us what the jump is from one track to the other, which is exactly why these numbers are going to be hard to interpret. So in order to interpret what a female coefficient of minus 0.3 means, you have to know this cut. Okay, so the important number at the end is going to be this number here. Okay? And what this number tells you is that, think about the distance between the best and the worst track. How much of that distance am I bridging just because I'm female? Okay. It turns out, if you know nothing else about those children, just being female pushes you almost 20% in the direction of the worst track compared to being male, okay, from the best one. The other thing I want to say is all our variables are going to be normalized. So even though you cannot compare them across regressions, you can compare them within a regression. Okay, so suppose now we control not just for whether they are male or female on what track they choose, but also for their objective grades. Okay? So if you're going to look at the second column where we control for their objective ability, the math grade, the GPA, and the relative math grade, you can see that the gender gap in choices, again, as seen in this by this variable f divided by the third cut to the first cut, increases. That's not surprising because girls are better than boys. So once I control for real ability, meaning grades, I'm going to have an increase in the gender gap in choices because girls are better than boys, and the best kids go to the most prestigious tracks, but girls choose less prestigious tracks than boys. The other thing to note is that the coefficient of female is almost twice as big as the coefficient on GPA. Okay? So in order to compensate being a girl, you have to almost have a 2 standard deviation higher GPA. Okay? So that's how you can compare variables within a regression. When we control also for subjective mathematical ability, like how good I think I am in math or how easy math is for me, then the gender gap in choices shrinks because girls actually don't feel very good about their math ability. Okay, but we're still left with a 15% gap, meaning that 15% of the difference between the best and the worst track is bridged just by being female. Okay? So it's this 15% that we want to understand. So let me tell you a little bit about experiments, and then we're going to combine the experimental result with the actual grades and the choices they make. Okay? So one question is whether girls are going to be indeed less likely to enter competitions than boys are, just as we saw with American undergraduates. And what is the potential impact of confidence and risk aversion on the choices of these 15-year-olds? So here's a table of the descriptive statistics of boys and girls. You can see that in our sample, in the round 1 tournament, boys are actually better than girls, But in the round 2 tournament, so the first time we do the tournament, there's no more gender difference in performance. Boys are a little bit better than girls, but it's not significant. Who is entering the tournament? Roughly half the boys are entering the tournament, but only 1/4 of the girls. Okay, so boys are entering at a much higher rate than girls are. Girls think they are better. They think they have a higher rank than the girls have. The average rank of the boys is 2.14, whereas for the girls it's 2.56. Boys are also more likely to pick more risky lotteries. Remember, the first choice of this lottery task was to pick either 2-2, or you could go up to the 5th choice, which was either getting 6 with probability 1/2 or 0 with probability 1/2. So girls are much less likely to pick high numbers, meaning that they're more likely to go for safer options. And when we ask them, how much do you see yourself? You're somebody who takes a lot of risk or not? Girls see themselves as less risk-taking than boys do. Okay, so let's put all of that in regressions. So this is an Orless regression of round 3 tournament entry, controlling for the actual performance in the tournament, the change in performance from the piece rate to the tournament, and the chance of winning the tournament. So this depends on my tournament performance compared to my classmates. And what you can see is that girls have a 23 percentage point lower chance of entering the tournament, conditioned on their actual ability of performing this task of adding up 4 two-digit numbers in 3 minutes. Okay, so the question is, how much of that gap of those 23 percentage points can be explained by either beliefs or risk aversion? So let's look at beliefs first and then risk aversion. So beliefs, this is guessed rank. You can see that guessed rank is significant. So the higher my rank is, so if I think I'm 4th compared to 3rd, the less likely I'm going to enter the tournament. It's highly significant. The gender gap reduces by about 1/3. When I add these risk questions, the gender gap again shrinks a little bit. Risk is, in this case, has an important impact on tournament choice. The nice thing is here we actually know much more about these children than we normally do about our undergraduates, because we actually have their math grades, we have the whole GPA, so we can add all of that in as well, and we're still left with a gender gap of almost 12 percentage points. Okay. So almost half, actually a little bit less than half, can be accounted for by beliefs and risk aversion, but then we have still this big portion left. So we found that boys are more likely to enter competition than girls, given their performance, by 23 percentage points. 1/3 was driven by beliefs, which left us 16 percentage points, and another 20% by gender difference in risk attitudes, which left us with an 11 percentage point difference in tournament entry between boys and girls in our sample. Okay, so now we want to bring these two things together. Okay. So the main question, remember, was controlling for academic performance. Does competitiveness correlate with this track choice? And then the second question is, well, can it help us understand the gender gap in those choices? Okay. So to do this, I'm going to go back to these ordered probability regressions. I'm going to take this ordering of track choices as given of math, biology, economics, and literature. And in our ordered probability regressions, we are now, in addition, also controlling for the performance in the round 1 experiment, in the round 2 tournament, the chance of winning the round 2 tournament. We control for all kinds of class fixed effects, school fixed effects, and so on. Okay. So remember, this was one of the regressions I already showed you. This is the impact of being female between choosing the most prestigious track and the least prestigious track. Okay, so this is this ordered probability regression, choosing either the most prestigious math track, then biology, then economics and literature. And we saw that being female bridges about almost 20% of the gap between choosing the most prestigious and the least prestigious track. Okay, so now the question is going to be, what's going to happen if we add, say, tournament entry to this variable? Okay. Like female, tournament entry is a 0-1 variable. I either entered the tournament or I didn't. Okay. So we can compare the two coefficients within a regression. Again, not across regressions, because you need to know these cuts. So it turns out if you have both variables in the regression, your coefficient in tournament entry is actually higher than on gender. And it's basically, well, so it's at least as high as gender. It's actually a little bit higher. The second thing to note, when you look at the gender gap in choices, it used to be 18%, and it goes down to roughly 14%. What it tells you is that adding this tournament entry variable, which is a 0-1 variable, accounts for roughly 26% of the gender gap in choices. Okay. So we have two things. First, my tournament entry variable is highly significant, and it has a large coefficient. It actually turns out if you had a choice of either just knowing their gender or just knowing whether they enter the tournament or not, you can see this from here because I don't show you the regression with just tournament entry. You're actually better off knowing if they just enter the tournament or not, okay, which is clearly a noisy variable of maybe their true competitiveness, whereas gender is it's a very good variable of their actual gender. Okay. But second, this tournament variable helps us understand a big fraction of the gender gap in choices. Okay, so now the rest of the talk is going to be helping us understand, well, how big is that fraction going to be if you can control for grades, if you can control for believed mathematical ability, what impact of that effect of tournament entry is coming from beliefs or risk aversion. So first, let's think about grades and mathematical ability. So again, we have seen this third column before when we just looked at the impact of GPA and believed math ability. Now what's going to happen if once we control for grades, we now add a variable tournament entry, we still have a significant reduction of the gender gap in choices of 20%. Okay. Again, once I have both female and tournament entry as a variable in there, my tournament entry variable has a slightly higher coefficient, and it can, so it's important. It seems to be an important trait for making these choices in high school. But second, it accounts for a big fraction of the gender gap in those choices. So we found that this competitiveness, this non-cognitive skill, significantly correlates with choices of study profiles once we control for grades and for feelings of mathematical ability. And as I said, the coefficient is up to, it's bigger than the gender coefficient. And controlling for competitiveness helps us understand, 20% of the gender gap in choices. So now the question is, how much of that can be explained by confidence and risk aversion? Right? We saw that tournament entry depends on beliefs and risk aversion. Maybe the impact of this tournament entry variable here is all driven by beliefs or is all driven by risk aversion. Okay, so I'm going to have to control for that. So the question is basically, what's the impact of competitive attitudes once we control for risk and beliefs? And the first thing I'm going to show you that we're going to still have a lot left. Well, first, otherwise I probably wouldn't talk about it. But second, so you can see it visually, is I'm going to show you the residual, how competitive I am compared to other people, controlling for beliefs and risk attitudes. Okay, so I'm going to show you my competitiveness when we take out beliefs and risk attitudes. And I'm going to show you this residual competitiveness of both boys and girls as a function of what track they chose. Okay, so what that means is I'm going to show you for the boys who take the math track, how much more competitive are they compared to other boys and girls once we take out beliefs and risk aversion. Okay, likewise for the girls. And this is the figure you get. Okay. So the boys who go to the math track, this is this one here, it's right here. The boys who go to the math track are very, very competitive compared to all the other children. The boys who go to the literature track actually, negatively competitive, so they're really not competitive. They actually look a lot like the girls who go to the literature track. The other thing you can see is that for both boys and girls, the more prestigious a track they choose, the more competitive they are, already taking out beliefs and risk aversion. This is true for girls, but this is really true for boys. Okay? For boys, this seems to be a very important trait, but it is also an important trait for the girls. Okay. So again, I think pictures are nice, because I think it's visually very obvious, but I want to convince you that this is indeed true once we also have our regressions. Okay, so this is something we have already seen. What's the impact of tournament entry on study track choices once we control for objective ability and for subjective ability, like my feelings on math. And we found that tournament entry accounts for roughly 20% of the gender gap in choices. So 20% of the distance between the worst and the best track is already bridged just by being female. Okay, so now we're going to think about what happens if we add a variable guest rank, right? This is where I said I'm either first, second, third, or fourth in my tournament. The first thing to note is if we just add the variable guest rank, this variable is not significant. Okay? So these beliefs on how good I think I am in this task in the tournament round has no impact on my choices. This was not correlated with my choices. If anything, if you compare this coefficient or that coefficient, the gender gap actually goes up. Okay? It's not significant, but it definitely doesn't go down. Okay? So what's going to happen if we now add tournament entry to it? Well, we still have tournament entry being an important variable. The size is still bigger than for gender, and we still are left with competitiveness accounting for a big fraction of the gender gap in choices, highly significant. What about if we're going to look at risk aversion? So we have two measures of risk attitudes. Remember, we have this risk question, like how do you see yourself, somebody who takes risk or not? And then we have this lottery choice question. Turns out that combined, they are significant, but if you have both of them there, only the lottery one is significant. But they do have an impact on the gender gap in choices. And when we add tournament entry once more, we get that the tournament entry variable is significant, and it again can account for a big fraction of the gender gap in choices. Okay. And if we add everything together, again, my entry variable is bigger than my gender variable, and again, then I can account for a big fraction of the gender gap in choices. Okay. So even after controlling for risk aversion, after controlling for beliefs, my tournament entry variable has a big impact on these choices, can help me understand these choices, and can help me understand the gender gap in these choices. Okay. So the result is that tournament entry is about us and offer more predictive of prestigiousness of study profile choice than gender is. Controlling for objective and subjective math ability, we found that competitiveness reduces the gender gap at 20%. And we also control for confidence and risk aversion. Competitiveness can still help me understand and reduce the gender gap by 16%. We also control for socioeconomic status, and then we still have the tournament entry helps me understand about, or have 13% of the gender gap in choices. Okay, so we did find a variable that seems to be robust, and it seems to really help me understand the choices children make in high school in the Netherlands. How about confidence? Well, confidence, we have already seen, is not significant correlating with choices. So confidence is not going to help me understand anything. That actually turns out to be true when you look at this in more detail. A bit more interesting is to think about risk aversion. Okay, what is the effect of risk aversion? How does it compare to competitiveness? So here is, again, this is the, when we just had tournament entry as a control, we have already seen that now we can explain 20% of the gap in choices. Suppose we just have risk aversion as a control, right? Forget about the tournament entry variable. I'm going to show you the gender gap in choices when I control for, well, female, the grades, but also these risk questions. Then the gender gap in choices is reduced by, it turns out, 16%. Okay? And that also turns out to be significant. Okay? Now, suppose I add both risk and risk and tournament entry. Combined, they can help me understand 33% of the gender gap in choices. That's almost the sum of the two effects. So it seems that competitiveness and risk attitudes, both of them are important, but they're almost orthogonal to each other. The reason we talk about competitiveness more than about risk in our paper is that the risk measure in our paper sometimes is significant, sometimes not. It depends a little bit on what regressions you pick, but how much you control for. The competitiveness measure is, in that sense, robust. It's a little bit bigger. But there's definitely something there. Okay, so there's something to understand on what is the impact on risk on making those choices. Okay. But as I said, they seem to be almost orthogonal. So both are important traits, but they have a different impact on those choices. Okay, so risk aversion. Students who opted for more risky lotteries do enroll in more prestigious profile choices, but these two effects are almost orthogonal: competitiveness and risk attitudes. And as I said, the effect of risk attitudes is sometimes weaker, sometimes not significant, but ranges from 6 to 18%. If you worry about confounds, don't. Okay. I hope you've read fast, because I want to tell you a little bit about, I have 10 minutes? I'm going to take 10 minutes, 5 minutes. I'm going to tell you a little bit more about maybe where to go next. Okay? So just to summarize, we found this competitiveness, this non-cognitive skill, or this psychological attribute, that is an important factor in educational choices. And I think we bridged the gap between the lab and the field by showing this external relevance of this trait. We showed that this trait that we found in the lab, that was so robust in the lab, we found that this trait helps us understand what we kind of want to understand anyway, which is why we have educational differences between what boys and girls study, in this case, in high school. Okay, so I think of that as establishing the external relevance of competitiveness, which is not the same as external validity. I think of it as external validity. Even if I run the experiment somewhere else, that is external validity. This is really telling me why my labor colleagues should care about this trait, okay, or my education colleagues. So where to go next? Well, as always, when you do something the first time, you really want it to be robust. Luckily, I know somebody has already looked at something like this in the US for choices of majors, but I know some of you here are French, so thinking about this in French high schools where you have the same kinds of choices to make just a year later might be interesting. What if we measure competitiveness in a task that is not a math task? Okay, so how does competitiveness, say, in the literature task, how would that help me understand some of these choices? What if we measure competitiveness earlier? Suppose I measure it maybe in the first of the last 6 years of high school as opposed to the third of these last 6 years of high school. What's the role of risk aversion? In our data, risk aversion was almost orthogonal compared to competitiveness. It was not always significant, but sometimes, and definitely was the second biggest effect that we had. So I think that's something to understand on risk aversion. We found that beliefs were not important predictor of choices in our case, but maybe we don't have a good measure of beliefs. Remember, we just asked them, do you think you were first, second, third, or fourth? Maybe we should assess beliefs better by potentially asking them how they update their beliefs over time. We also found that what is very important is how good they are in math, whether math is easy for them. It could be that it's indeed a true insight on their actual math ability, but it could also be that girls who say math is hard for them, this is also a kind of belief. It's not a belief on what their chances of winning the tournament, but the question is, where does this come from, and can I potentially find a variable that helps me understand better why girls feel that they're not so good in math and that math is hard for them, because those beliefs on how good you think you are in math have a huge impact on those choices. Disentangling that from actual math ability, I think, would be also an interesting way to go, trying to understand where this comes from. How about other behavioral variables, such as hyperbolic discounting? Can that help us understand the choices these children make? I have no idea. Given that we found that competitiveness helps us understand these track choices, now we have some new questions. In the environment in the Netherlands, as it would be if you would run this in France, say, prestigiousness and how much math and science you have is highly correlated. In Austria, I actually went to French schools. I don't know too much about Austrian schools, but in some schools in Austria, the most prestigious thing to do is to study Latin and ancient Greek. Okay? So maybe there it would be different. Is it about how much math and science there is, or is it about how prestigious it is? So far, the two of them were perfectly correlated. I don't know how it would look like if they were not perfectly correlated. What helps us understand competitiveness? Now that we showed that it's such an important trait, I think it would be useful to try to understand it better. How is it different or the same from ambition. Challenge seeking, grit, that's another big hit in the psychology right now. How does this correlate with competitiveness? I don't know. What are other psychological traits that correlate with competitiveness? Can we manipulate competitiveness? Can we make, potentially, both boys or girls more competitive and therefore affect their choices? The second thing, which might be important to understand, and hopefully we will know very soon if we have cooperation with our schools, is that there are two ways to think about the role of competitiveness. We saw that it has an impact on what track they choose. So what we have is we have some boys who are actually, some of them not that good in math, but very competitive, who chose the math track. Okay, and then we have some girls who are very good in math and not so competitive, who also choose the math track. The question is, who is going to perform better? How important is that trait competitiveness, not just for making the choice of going to the math track, but for succeeding condition having made that choice? Okay, so these children are now in the last year of high school, and hopefully in the summer we're going to get the data from the schools where we're actually going to get to see their final grades. So we're going to have some idea on this. The reason this might be important is that suppose we find that competitiveness is only important for making the choice, but not for succeeding condition having made that choice. What that means is that we created an environment that is a variable, competitiveness, that has a big impact on choices, and that's it. It doesn't have an impact afterwards on performance. If that is the case, maybe we should change the way we have people make choices. I think of that as changing the choice architecture. In Europe, we love these once and for all choices. Okay? You go in the Netherlands in school, in France in school, you have to make one choice, you choose your study track. Once you choose this track, you're basically trapped. Because even though math is the most prestigious one, if after 1 year you find out you're not that good in math, it's actually very hard to switch because you're missing, say, another language to go to the literature track. Okay? In Europe, in college, you basically immediately say, I want to study math, I want to study literature or comparative theater or whatever. In the US, they have much more gradual choices. In the US, there's no more gender gap in how much math boys and girls take in high school. You can have a math class, you take one, you see how well you do. If you like it, you can take another one. You don't have to commit ex ante. Okay, so it could be that having these once and for all choices may really exacerbate some of those gender differences in choices. Or not. We're going to find out hopefully soon. I think that's a big question. This is going to have a big impact on how we think about organizing our education system. Another way, of course, is potentially thinking about single-sex classes. We found that, in general, gender differences in competitiveness are much reduced when women or girls have to just compete against other women. So it's not that women don't like entering tournaments or competitions at all. They just don't like to do it, or they don't do it when they have to compete against men. Okay, so one way to think of that as a bigger gender is, are there traits in which women and men differ that can account for some of these gender differences we have seen on the labor market and in education? Altruism risk is what people have talked about the most, but I think recently we have developed other gender differences in the lab, like competitiveness, willingness to negotiate, to speak up. And then, of course, the question is, how can some of these lab differences help us understand some of these bigger differences we find in the labor market? This is thinking about external relevance. And then as a bigger question, where should we go with this? There are kind of two things we can do. We can try to change the women, make them more competitive or whatever, if that even helps. And the second thing is potentially we can think about changing the institution. Right? And there has been, Claudia Goldin gave an address at the AEA meetings saying that having flexible work hours, meaning you don't have to work 8 hours a day, seems to be important for keeping lots of women in the jobs. Maybe gradual choices in schools are going to have an impact on how much math and science girls take, and hopefully in a few years, you guys will have added to some of these question marks. Thank you. Yes. Yes. So I'm a big fan of the psychology literature. I think it really, when I was in grad school, I took one of the main, actually two of the main social psychology classes, their main introductory classes, their grad classes. It was great. It really, I find it gives me a lot of motivation, a lot of ideas. But when you think about stereotype threat, which I think is what you're talking about, it's sometimes very hard to translate this directly to economics. So I think it would be nice to do potentially a stereotype threat experiment as well. But let's just think about tournament entry or tournament performance. So in the stereotype threat literature, it turns out one experiment is I can present a test to you in two ways. I can tell you this test is really going to tell me if you're in the bottom 20%. Okay? Then the ones who do badly are the women who worry that they are in the bottom 20%. And the idea of stereotype threat is that there's this additional threat in the air that I'm going to fail just because I'm a woman, but actually I like math. So I'm going to be extra nervous and I'm going to fail. Then they have a test where they say, it's the same test, that's what psychologists can do and we cannot as economists. And they say, this test is going to tell me whether you're really in the top 20%. Now the people who are going to be extra stressed are the men. When you think about my very first paper I did present, where we look at performance differences in a tournament. Well, who is going to win the tournament? It's the best people. So if I translate this directly, I almost would get that the men would perform worse, which is not what we find in our experiments. So I think sometimes, I think it's very interesting. I don't know how to translate some of that directly to this. So I think it would be nice if more of this gap would be bridged between economics and psychology. I find that papers often, and the talks especially, are often very, very good. No pressure, Raj. But it's sometimes hard to translate for us. So I know that literature very well, I just don't know what to do with it.